The statistical procedures reviewed in the last lesson focused on the comparison of a measured dependent variable across categories of an independent variable. These procedures are generally applied to experimental and quasi-experimental designs for the purpose of group comparisons. We will now begin to examine procedures for exploratory analyses, where the purpose of the research question is to evaluate the relationship between two measured variables. Where statistical tests of group differences address the question, is group A different from group B, or does this treatment cause this outcome? Measures of correlation and regression ask, what is the relationship between A and B? Or can we predict variable B if we know variable A? Correlation is basically a measure of association between two variables. How much is the variation in a variable related to the variation in another variable? If there is a strong correlation between two variables, then regression statistics may be used to predict a variable when only one is known. For example, a medical researcher might want to use body weight to predict the most appropriate dose for a new drug. The purpose of running a regression analysis is to find a formula that fits the relationship between the two variables. Then you can use that formula to predict values for a variable when only one variable is known. A doctor could prescribe the proper dose based on a person's body weight. A correlation coefficient is a statistic that indicates the strength and direction of the relationship between two variables. It provides a single numerical value to represent the relationship. Correlation coefficients can range from a -1, a perfect inverse relationship, to +1, a perfect direct relationship, with a value of 0 indicating no relationship. When determining correlation coefficients, the most common statistical analyses are the Pearson R and the Spearman Rho. The Pearson R is best used when both of the variables are racial or interval type. The Spearman Rho is best used when one or both of the variables are ordinal. When reviewing the correlation coefficient, this table offers a general guidelines as to interpretation. Where 0.00 to 0.25 is little to no relationship, 0.25 to 0.50 is a fair relationship, 0.50 to 0.75 is a moderate to good relationship, and above 0.75 is considered to be a good to excellent relationship. It is often useful to examine a statistical relationship by first creating a scatter plot as shown on this slide. In a scatter plot, each point or dot represents the intersection of a pair of related observations. With a sufficient number of data points, a scatter plot can visually clarify the strength and shape of a relationship. Let's look at a scatter plot in Excel. For this exercise, you need to go back to the week within which you found this presentation. Open the Excel 2010 spreadsheet that I've created that has energy data. You must use the 2010 version of Excel or higher for this exercise. These are data from 19 months of electric and gas use for a residential home. When you open the energy spreadsheet, it should look like this. There are 19 months of data which include the following for each month: average temperature, electricity use, electrical charge, gas use, and gas charge. I honestly don't know the units represented for the electric or gas use categories, but that information will not be necessary for our analysis. Let's make a scatter plot of two of the sets of data in this spreadsheet. Hold down the left mouse button and capture the two columns of electric use and electric charge. Then, go to the menu at the top of the spreadsheet and choose Insert, then pick the scatter plot option shown on this slide. You will then get this graph output on your screen. One of the first things I always do is grab an edge of the graph area with the left mouse button and make it larger so it is easier to work with and to see. Now, under Chart Tools Design at the top of the page, choose the top left option for the format of this graph. Now, with this graph output, first delete the legend on the right-hand side. Then, add a title for the graph and also for the X and Y axes. As can be seen by reviewing this graph, it looks like there's at least a moderate or higher correlation between these two variables. Now let's complete a statistical analysis and get a correlation coefficient to go along with this scatterplot information. The statistical analysis to determine if a relationship exists between two sets of racial or interval data is the Pearson product moment correlation coefficient, usually simply referred to as the Pearson R. The information regarding this analysis is covered on pages 520 to 530 in your required text. The statistical analysis to determine if a relationship exists between two sets of ordinal or nonparametric data is the Spearman rank correlation coefficient, usually simply referred to as Spearman's rho. The information regarding this analysis is covered on pages 531 to 532 in your required text. Let's first look at calculating the Pearson R for the parametric data we previously graphed when comparing electric use to electric charge. Go to the website listed at the top of this slide. You will initially see a pop-up box asking you to enter the number of paired values. We will be comparing the electric use column with the electric charge column, which has a total of 19 paired values. Try to first go to the website and see if the pop-up box shows. If it doesn't, you'll probably need to change the security settings of your browser. At the bottom of this slide, I've shown how to do that for the Internet Explorer browser. Go to Tools or Internet Options and change the security setting to no higher than medium-high. You may also need to go to the Privacy tab and turn off the pop-up blocker. When you're able to access this site with the pop-up showing, enter 19 for the number of paired values and select OK. Now, enter the values for electric use in the X column and the values for electric charge in the Y column on the website and select Calculate. The R value in this case, which represents the strength and direction of the relationship, is shown as 0.982. This is a positive correlation and a strong one based on our original chart noting that a correlation above 0.75 is a good to excellent relationship. We can also look at the two-tailed p-value or test of significance associated with a Pearson R. It is shown as less than 0.0001. If this p-value is 0.05 or less, it supports a relationship between these two sets of data. If the p-value is greater than 0.05, it does not support a relationship. Together, an R value of 0.982, along with a two-tailed p-value of less than 0.0001, supports a very strong relationship. When a strong correlation or relationship exists between two sets of parametric data, a regression equation can also be developed. This equation can be used to make predictions. We developed this equation using the slope and y-intercept values given when we calculated Pearson R. You can see that the regression equation is written as y equal to the slope times the x plus the y-intercept, which could be a negative number. Therefore, in this case, y equals 0.1x plus 4.893. We can now predict how much a certain electrical use would cost. Let's say we want to estimate the cost of 950 units of electricity. The cost or y value would be equal to 0.1 times 950 plus 4.893, or $99.89. The Spearman rho is the nonparametric analog of the Pearson R to be used with ordinal data. The example of the proper use of this analysis is shown in your required text on page 532. The scores for verbal and reading comprehension are based on an ordinal scale of 1 to 100. To run a Spearman rho analysis on these data, go to the website listed on this slide. Again, a pop-up box will appear asking you to enter the number of XY pairs, which is 10 for this example. Then select OK. Enter the data from the example on page 532 of your required text in the raw data columns. you'll see that when you select Calculate from Raw Data, the rankings will also then be shown. In any problems I give you, you should use the raw data columns when using the Spearman-Rho calculator at this website. The analysis now shows a correlation coefficient of 0.7939, which is rounded to 0.794 in your textbook. This correlation is above 0.75, suggesting a good relationship between these two sets of data. The two-tailed p-value is shown as 0.00613, which confirms the relationship is significant. Note that your text uses the one-tailed p-value of 0.003, whereas I always prefer you report the two-tailed p-value. This completes the presentation on correlation and regression. Be sure to read the referenced material in your text for increased understanding, and go back and review the information in this presentation as needed. You'll notice there is much more information in the text regarding correlation and regression, but the basics are covered here, and several weeks could be spent investigating the depths of these topics.